Hi, this is sort of our last in a series of theorems that we're going to use to manipulate complex numbers using their trig form. And this one's called the division theorem. We just learned about the multiplication theorem and De Moivre's theorem. So this is going to be very similar. When we think about multiplication, we were multiplying those two moduli together, and then we were adding their arguments. When we divide, we have to divide in order, but we divide those two moduli and we subtract their arguments. So whereas when we multiplied these things, um, we had to turn counterclockwise. When we divide these things, we're going to go right back clockwise. So this is our theorem here. We divide the moduli together, and then we subtract those arguments here. So we're going to do a couple of examples here. Let me go ahead and share my doc cam here with you. So here's our theorem, and that first one was we have 18 cis 51 degrees and 12 cis 32 degrees. So these numbers are already in their trig form, and we're going to go ahead and divide. So using my theorem, going to be pretty easy. I have dividing the moduli, I get 18 divided by 12, and then I just subtract their arguments here. So dividing 18 by 12, I think 6 goes into both of those, so I would get 3/2 or 1.5 times cis, and then 51 minus 32 is like 52 minus 32 plus 1, so, or minus 1. So 52 minus 32 is 20, minus 1 is 19. So that should be my product here. If I wanted to draw this on my complex plane, notice their moduli would be divided. So they start out pretty far away from that 0, but now they're going to be close because we divide those moduli. So I'm only at 1.5 from that origin. I'm at 19 degrees, so it's going to be really small in here. It's going to be right about here. So this would be 1.5 with an angle of 19 degrees there from the real axis. So that's going to be really close there. All right, let's look at one more application of the division theorem here. So I'm going to zoom out just a little bit so we can keep that on our screen. And this one, we're going to find this division in two ways. So we're going to do z1 divided by z2 the long way, and then we're going to use the theorem. So if I do z1 divided by z2, there is, and you might see this automatically, there's a really easy way to do this, but if we're thinking about dividing through the way we were taught by using the conjugate, we're going to do it that way. So I have 2 plus 2i all over 1 plus 1i. So we were taught to use the conjugate of the denominator. So the conjugate of the denominator is 1 minus I. So I'll just multiply by 1 minus I in the numerator and the denominator. So working with the denominator first, we should get a real number. I have 1 times 1. I have minus I. I have, when I distribute the I through, I have plus I. We knew that was going to happen. And then I have minus I squared. So these subtract out. I have 1 minus I squared is a -1, so that's going to be 2. Let's go ahead and fill in the numerators. I'm going to distribute just like I did. So I have 2 times 1 is 2. 2 times -I is -2i. 2i times 1 is plus 2i. And 2i times -I is minus 2i squared. Again, these are going to subtract out. It's not totally a number times its conjugate, but it's one scaled times the conjugate of the other. And I have 2 minus 2 times -1, because I squared is -1, and 2 plus 2 is 4. So this is going to turn out to be 2. And if you saw the easier way to do it, good job. But yeah, we're just going to get 2 there. Okay, so now let's go ahead and use our trig form to do this. So converting those into trig form, you might see that both of these are going to be 45-degree angle triangles. So I have 1 to 1 to root 2, and I have 2 to 2 to 2 root 2. Both of those angles are going to be 45 degrees. So my numbers turn out to be Z1 in trig form is going to be 2 root 2 cis 45 degrees. And Z2 turns out to be root 2 here times cis of 45 degrees. So what does our division theorem say to do? I'm taking Z1 dividing by Z2. Let's bring it down here. It says to divide the moduli and then subtract those arguments here. So that's what we'll do. So in this case, I'm going to go ahead and divide the moduli when we convert those into trig form. Dividing that, I get 2 root 2 over root 2, and then I have that shorthand notation cis of 45 degrees minus 45 degrees. Of course, 2 root 2 over root 2, the root 2's factor out, so I have 2, and then 45 minus 45 is 0. So I end up with 2 cis 0, and that one's going to be 2 cosine of 0 plus I sine of 0. And we know that cosine of 0 is going to be 1, and sine of 0 is going to be 0. That just gives us 2, which totally checks out with this division. So when we divide those, since we're dividing the moduli, and 2 divided by 1 is still 2, we're going to be out here at 2. And then when we take 45 degrees minus 45 degrees, it's just going to bring us back to that 0-degree angle. All right, so I hope that these series of videos have helped you process the idea of De Moivre's theorem and working with these complex numbers in trig form. Thanks.